Welcome back. In today's class, we will be solving again a few more problem sums based on square, square root, cube and cube root, which are of level 1. In the first problem, what we have to do is we need to simplify cube root of an expression. So whatever expression is given as multiplication of few other terms in the numerator and denominator, since we will be finding out the cube root, so what our aim will be, we will try to express every term as cube of some value. So first we will do that and then we will see how we can simplify further. So we have expressed every term as cube of some value and then finally we will be finding the cube root. So if individually we evaluate, then for this term it will be 3 square. Then for the second term it will be 4 only, as this q and then multiplied by 1/3. This 3 in the denominator and this 3 in the numerator will cancel each other, and that will work for every term. And then the third term in the numerator will be 2 square, again the same concept. Then in the denominator we will have 8q, and then multiplied by the second term where we will have only 2. So further it will be 3 square means 9. Here we will have 4. Then again here we will have 4. And then here we will have 8q means 8 multiplied by 8 multiplied by 8, and then we will have 2. So further we can write 9 divided by, here we will have 2 2s are 4, 4 2s are 8, and 8 8s are 64. So this will be our final answer. Now the second question asks that the cube of a number ending in 3 ends in which number, or which digit we will have in the units place if we take the cube value of a number where in the units place the digit in that number is 3. So let's take an example. If we take a single digit number like 3, so if we if we multiply 3 again by 3, if we take the square value, then it will be 9. And then 9 if we multiply by 3, then it will be 27. So if you take the cube of 3, then this value is 27, and at units place the digit is 7. Now if we consider a 2-digit number where the digit at units place is 3, so that will be 13. If we take that value and if we take the square value, then it will be 169. And if we take the cube value, means 169 when it is multiplied by 13, then that is 2197. So again in that cube value at units place we have 7. Now the third question, if n leaves a remainder 1 when divided by 2, then if or when nq will be divided by 2, then it will leave what remainder. So it apparently looks that when we divide a number n by 2 and then it leaves a remainder 1, so when we'll be considering nq, the q value of that given number, and when we will be dividing by the same value 2, then it will leave 3 times remainder, means 3. Well, let's see whether that is true or not. So let's take an example, say 5. 5 when it will be divided by 2, we know that the quotient value will be 2 and remainder will be 1. And if we consider any odd value, any odd number, and if we divide by 2, then always the remainder will be 1. That means this n, in the question the number that is given n, that is actually an odd number, and when that will be divided by 2, always that will leave a remainder 1. Now if we consider, or if we take the cube value of the number that we have chosen, 5, so that value will be what? That value will be 25, then multiplied by 5, so it will be 125. Now again this is an odd number, so 125 when it will be divided by 2, so again that will leave some quotient which will be 62, and then the remainder will be 1. So that means if we take an odd number and if we divide by 2, we know that remainder value will be 1. If we take the cube value of that odd number and again if we divide by 2, that will be again an odd number. So if we divide by 2, that will again leave a remainder 1. It's not 3 times, it's always it will be 1 only. Now the fourth question. The length of a diagonal of a square plot is 24 centimeter. then find the area of the square plot. So let's consider a square plot. So ABCD in this figure is a square where BD is the diagonal, and as per the question or as per the problem statement, the length of that diagonal of that square plot is 24 centimeter. Fine. And we know this triangle and this triangle, both the triangles which we have obtained by dividing this square by this its diagonal into two equal triangles, and both the triangles are right angle triangle. Now here BC, and if we consider this triangle, then we know that BC this side is equal to CD, that value, and that if we consider as A, then from Pythagoras theorem we know that BC square plus CD square, that will be equal to BD square. So BC square means here A square, and CD square means again A square, and BD square that is given in the question, which is 24 square. So you can say 2A square is equal to 576. That means A square will be equal to 576 divided by 2. So that will be, and what is A square? If the each side of a square is A, then A square or the area of that square will be A square. So A square is 288. That means the area of the square plot that we were supposed to find, that value will be 288 centimeter square or square centimeter. Now in the next question, we have to find the smallest number by which 2592 should be divided so that the quotient is a perfect cube. So this time we want to divide the given number so that the quotient will be cube. So in this type of problem, what we do is we factorize the given number. We try to find all the prime factors, and then based on that we take some decisions or we calculate further. So if we factorize 2592, this will be like this, where we will have in total 5 plus 4 9 factors. Among them 2 is one of the prime factors, and 3 is the other prime factor. So 2592 can be written like this, where we can see that we have 1 2 3 4 5 2 and 4 3. And what is our requirement? We have to divide the given number by such a number so that the quotient is perfect cube. So that means if we rearrange all these factors like this, 2 2 2 here, this 3 2, if we club together, then that can be written as 2 cube, and here we have 4 3. So if we choose 3 3's first, and that if we represent as 3 cube, then the remaining factors are what or how many? We have 2 here left, so 2 multiplied by 2, and then here we have 1 3 left, and these remaining factors could not be expressed as cube value. So here basically the cube is 2 multiplied by 3, and this is the extra factor that cannot be expressed as cube values. So the given number 2592, if we divide that number by these remaining factors, the multiplication of these remaining factors, 2 multiplied by 2 4, 3 is 12. So if 2592 is divided by 12, then the quotient will be a perfect cube, and that will be cube of 6. And here we need to find in the question smallest number by which 2592 should be divided, and this is the smallest value, this 12, because here we have 2 cube, then 3 cube, and then 12. So if we divide 2592 by this value 2q and multiplied by 12, that value, then the quotient will be 3q. So that is also satisfied. And if we divide 2592 by this value 3q multiplied by 12, then again the quotient will be a perfect cube, and that will be 2q. So that is also valid. But among these three values, we have to choose the smallest number by which we will divide, and then the quotient will be q, and the smallest value will be 12. Now in the next question, if a is a natural number and it can be expressed as the sum of the first b consecutive odd natural numbers. So sum of first b consecutive odd natural numbers, then what could be the value of this expression a minus b square? Let's choose any arbitrary number, say 9. and 9 if we express as consecutive summation of consecutive odd natural numbers, then it will be 1 plus 3 plus 5. So that is satisfied as per the problem statement. Now if we choose say 16, so 9 16 both are natural numbers and they are represented as the sum of first b odd natural numbers. So what we can see here is that here we have three odd natural numbers, consecutive three odd natural numbers, and their summation is 9. So that can be expressed as 3 square, right? And here this is the summation of first four consecutive odd natural numbers and their summation is 16. So that can be represented as 4 square. And if we extend further, then it can be represented as 1 plus 3 plus 5 plus 7 plus 9. So 25 can be represented as this, where this is summation of first 5 consecutive odd natural numbers. So that can be expressed as 5 square. And this is basically one of the properties of square numbers. So what we can conclude is here a 9 16 25, they are what? They are, as per the question, is a, and this number is what? This 3 4 5, this is first b consecutive odd natural number. So basically 3 4 5 are b. Now a minus b square then will be what? A is, as per the first example, a will be 9 and b will be what? B is 3, so b square, so 9, it will be 0. As per the second example, a will be 16 and b is 4, so b square will be 16, so that will be 0. And that is applicable for any number which satisfies the condition which is given in the problem statement. And always this a basically will be a square number. Now in the next question we have an equation of x, and that is given in the form of exponents. So 7 to 9, this if we represent, so 7 to 9 can be represented as 3 to the power 6, and then we have its own power, which is x plus 3. And then on the right side of that equation we have 27, which is 3 cube. So cube of 3, and then again we have power of that, which is 5 plus x. So this can be again written as 3, and then this power will be, we know they are basically multiplied, so this will be 6x plus 18. And then on the right side we will have 3 to the power, this will be 15 plus 3x. Since on both the sides the base are same, so we can equate their exponents values or their powers. So it will be 6x plus 18, and that will be equal to 15 plus 3x, and this is nothing but a linear equation in one variable. So 6x minus 3x, it will be 3x, and 15 minus 18, it will be minus 3, and from here the value of x will be minus 1. So the value of x to the power x will be how much? It will be minus 1 to the power minus 1. So it can be further written as 1 divided by minus 1 to the power plus 1, and finally that value will be minus 1. Now in the next question we need to find the maximum number of consecutive positive odd numbers to give a sum of 3844. It sounds same as the problem that we have just solved. So first what we'll do, we will check whether 3844 is a perfect square or not. So 3844, basically it is a perfect square, and square of what? Square of 31 multiplied by 2, so it is square of 62. So 3844, if we express that as summation of consecutive positive odd numbers, then it will be 1 plus 3 plus 5 plus 7 plus 9, and this way in that series we will have totals 62 terms. That means the answer of this question will be the find the maximum number of consecutive positive odd numbers. So that value will be 62. Now in this question we need to find the value of root over 32x, and we have been given an expression where we have x also. So from there we need to find the value of x first, and then we will put that value of x in the expression or in that square root value, where within that square root we have that expression 32x. So this 3 and this 3 will cancel each other, same as for this 2 and for this 3. So what will remain is, from the first term it will be minus 3, then from the second term it will be 27, and then from the third term it will be 6 and then minus 6. So it will be minus 6 and that value will be x. Finally x will be 18. Now what we need to evaluate is 32 multiplied by x and then square root value of that. So 32 multiplied by 18 and then square root of that. Finally it will be 3 2s are 6 and 6 4s are 24. Now in the next question, which is the last question of this class, we need to find the value of x from the given expression. So in this type of problem, what we will do is, first we will factorize the number which is given, and then we will try to express as the exponents of some other prime factors of that given number, and then we will equate the base, and from there we will try to find the value of the x which is in the exponent or in the power. Now if we factorize this 87880, we will factorize by 2, but since in the problem statement is given that 2 cube, 8 will be one of the factors of that given number, so I have directly divided that given number by 8, as this was already known to me. Now since again 5 to the power 1, 5 is another factor of that given number, so next I have divided by 5, and then the remaining number, which was 2197, the quotient value after dividing by 5, that value I have divided by 13, because that was again known to me. The 13 was one of the factors of that given number. So when I divided by 13, then I got 169, and we know that 169 is basically square of 13. So this 87880, that can be represented as, so we can say, and that in the question that is given as 2q and then multiplied by 5 to the power 1 and then multiplied by 13 to the power x. Then from these two lines we can say x will be equal to 3. So I hope this class was interesting and meaningful for you. With that hope I end today's class. Thank you.